Okay, I just want to tag on with where the last video left off. So we have now this estimate for our acceleration of g of 10.05, and this is going to be in meters per second squared, which again is not a bad estimate compared to the accepted value of 9.81. And to finalize how close this is, we can run a linest value. So I'm going to highlight two columns and about 5 rows. And I'm going to hit equals linest. And you can only run a linest function for a linear line. So I cannot run a linest function. Um, it's wanting me to go ahead and put in the function, but I can't run it on my parabola data. I can only run it on my linear data. So again, highlight your known y values, comma, the corresponding x values that go along with each of those measurements, comma 1, hit Control Shift Enter, and we should now have our uncertainties. Okay. Now, before we go on, let me also come back to our parabola and let's interpret this equation. So 5.01 points, or yeah, 501.79 represents our 1/2 g, right? And that means that the 38.116 represents our initial velocity, and the 0.1865 represents, whoops, wrong frame, the initial position. Okay, so if I convert all of these to meters by moving the decimal, then what this means is that this is 0.38 meters, uh, and this is going to be a really small number, 0.001865. So what that means is that the golf ball, had just started to fall in the frame that I took, so it already had some initial velocity. It had some non-zero initial velocity. Its velocity was approximately 0.38 meters per second, or 38 centimeters per second, but its initial position, it hadn't fallen very far at all. All right, so that's what these numbers correlating with this equation mean. All right, that's how to interpret those. Okay, so now back to our uncertainties. All right, if I convert everything into meters per second squared, then I'm going to divide by 100, so that's going to be 10.05. And I'm going to just keep two decimal places. I'm going to round to two decimal places. That seems like the most reasonable thing to do. And so that really gets rounded up to 10.6. And my uncertainty on that is going to be 0.15. Remember, your uncertainty must match the number of decimal places in your measurement, and if I divide 14.56867 by 100, then I'm going to get 0.1456, blah, 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 blah. So when I divide by 100 and then only keep two decimal places, this gets rounded up to 0.15. Now, what this means is that I have a maximum and minimum range for my acceleration, okay? And so my maximum acceleration, or my maximum g, is going to be found from taking my measured value plus my uncertainty, and my minimum value is going to be found by taking the the measurement minus the uncertainty. And what we're really saying is that our measured value of gravity actually really falls anywhere between these two extremum. Okay, uh, so we're claiming that our value is 10.06, but we really don't know any better than to say it's really between 9.91 and 10.21. Ideally, the goal is to measure gravity to be exactly 9.8. Of course, that's likely not going to happen, but you may be able to get 9.81 to fall within your uncertainty range. We didn't here, but we're really not that far off. So overall, I would say this is a fairly successful experiment. Even if we didn't exactly hit it on the head, we can claim that we are fairly precise, and that's because our uncertainty on our acceleration is fairly small. Even if we're not completely accurate, we didn't exactly hit the bullseye. Okay. But so when you're doing your report and you're doing your measurements for the three objects, the golf ball, the ping pong ball, and then the falling mass, um, the question really is threefold. Number one, how close did you get to 9.81? Number two, uh, if you didn't get close to 9.81, can you explain why you didn't, or are there any factors that might cause you not to get 9.81? And then number three, what is your uncertainty? How precise are your measurements? So as you're going through your experiment this week, those are the things I want you to focus on. All right, I hope you find these videos helpful, and we will talk to you next time.